Another one which is just a regular group. Wait, pause it. It is important to know that control is one of the basic principles of statistical designs of an experiment, because without it, there would be a strong presence of bias. Alright, now let's move on to randomization. Which is the use of chance to divide experimental units into groups. This is essential to try to get a good experimental design, because without doing this, bias may be introduced into the experiment. For example, you do random assignment, which you could do this by like tossing a coin, rolling a dice. Then by doing this, you split them up into groups. Group 1, Group 2. Then you give each group a different type of treatment. Then you compare the data. Okay, pause it. Right. Make sure that you use enough experimental units to reduce the chance of variations within the experiment. Okay, because alright, pause it. Okay, the basic principles of designing an experiment. Oh, that's a P, not a B. 1. Control the effects of working variables on the response simply by comparing two or more treatments. 2. Randomize. Important. It's important that you use impersonal chance to assign the experimental units to treatments. Number 3. Make sure that you replicate each treatment on many units to reduce the chance variation in the results of your experiment. Okay, if you did this correctly, completely randomized designs are when all experimental units are allocated in random among all treatments, which means like it's completely randomized, there's no bias, or there's a really low chance of bias.
Alright, 5.3, simulating experiments. So simulation is the imitation of chance behavior based on a model that accurately reflects the experiment under consideration. So there are 5 steps to do this. Step 1 is state the problem or describe experiment. So, oh wait, pause it. Okay. So for example, you toss a coin 10 times. So to state the problem, you would write, what is the likelihood of a run of at least 3 consecutive heads or 3 consecutive tails. And then step 2 is state assumptions. And then pause it because I need to look. So there are 2 possibilities. So either head or tails can occur. And then just pause it. Alright, so step 3 is assigning digits. So for this one, if there are 70% of people that are employed, 0 to 6 are employed, and 7 to 9 are not employed. Then there's step 4, simulate many repetitions. So repeat this about 10 times. Then we got the last step, which is make conclusions. And that's it. So to use a calculator to simulate an experiment, you'd go to math, you'd go to probability, you'd click 5, and some example numbers would be 0, 9, and 5. And then you click enter, and that will generate 5 random digits. And then that's it.